After coming up with the design for the stand for the flywheel, I discovered that I needed to add some stoppers for the bearings to the shaft of the flywheel. So we had to load the flywheel on a truck and move it to some place where I could get power to do the welding on the stoppers. So once the welding was done, I then worked on the stand. The stand has the core part that is made from the same material as the shaft, because that's what bears most of the weight. But then there were those outer triangular stands that I had to add because of the nature of the bearing that I was using for this setup. Because this is the type of bearing that I could get. It was a wedge-shaped roller bearing that kind of requires it to be at attention for it to function properly. So I had to add some external supports to the core stand, against which I would pull the outer housing of the bearing, as you'll see later during the bearing assembly and also during the first run of the flywheel. So I used some heavy gauge plates, and drilling was a bit tedious, so I had to resort to using the arc to drill most of the holes that I use for the bolts, because getting them to also like line up precisely using a drill was a bit hard. I also had to create some spacers for the shaft, because the bearing that I could fight is actually an old bearing. It's a second hand bearing. It needed spacing because its bearing size is the part number is 32 to 17. It's for fuso, and it could not fit the 3 inch, so I had to put in some spacers. I also put in or designed some stopper mechanism that would make sure that the inner part of the bearing stayed in place as the outer the housing of the bearing was being pulled outwards, and this would make sure that we do achieve the tension that I was talking about once the wheel was suspended on the bearing. I had made sure that the spacers and the locks are going to use bolts, because that way I could get the locks to be put in place tightly by tightening on the bolts and tensioning them, and also the force was perpendicular to the force of the bolts, so I didn't need like some very heavy gauge bolts for this. I just needed some bolts to hold the cup in place to make sure that the bearing does not move. So I had to do it for both sides of the flywheel. So this side was a bit wide, and this was by design because I need to add some metal, or I'll say a flat plate all around the wheel to help with the wheel balancing. So for this side I had left a big allowance. So after that we brought in the stand, and then we held the wheel perpendicularly in a balanced position. I had my friend help me do this because I needed it suspended this way. I could not support it on something at this stage, because I needed the shaft free and with a lot of space so that I could tighten all the necessary bolts. So that once that was done, it was our first attempt to try and get the wheel up. The first attempt was try to roll it up a plank, and then it would the stud would hang, and then would lower it with the stud, but it wouldn't budge because, as I said, it's very heavy. It's at least 300 kgs. So then after that, came up with the idea that we try and lift it by the shaft. I knew this was not going to work because I know it's a very heavy flywheel, but it was nice to just try and be sure that it's not possible. And as you can see, it was just not possible. And so I had to come up with a leverage mechanism, and that's what we used to get it to where it is now. I had put some stoppers because I didn't want us to leave it and have it go all the way uncontrollably. So once we get it to this point, we balanced it so that the weight would be vertical, and then we removed all the stoppers that we had put down there. And then once these would be removed, then I shifted the planks to the other side to at least try and slow down the descent. I knew at this point we could let it go, but I still didn't want to just let it go and follow the stand. I wanted us to try and put in some resistance to that whole process. And it was heavy, and I knew we couldn't like putting a lot of resistance, but even a little resistance would have helped a little bit. So I moved the planks to the other side. So now instead of lifting, they will be slowing down the fall, because from this side we were lifting, but now from the other side we'll be slowing it down because now it wants to fall into the stand. So as you can see, we did our best to try and slow it down, but it was a bit too heavy. I would say we did almost nothing to slow it down, taking into account how heavy it was. Yeah, but as you can see, everything went on fine, and the wheel landed nicely on its stand. I was happy about that, and as you can see, my friend was very eager to give it a fast spin. This was like the very first time that I was watching the wheel spin. So yeah, it was a very happy moment for me. So I give it a look to see how much bend it had. I had done my best to try and put it as level as possible during the pouring. So after some inspection, I discovered that the bearing was not in fully, and that's why we had a gap at the top between the rollers and the actual bearing, because I had put it all the way, but it seems like I will have to increase the space, so I need to reduce the length of the tensioners, so that I would also get some more space to pull it further, so that the rollers get fully into the bearing housing. But otherwise, the wheel spins fine. I've spun it at quite reasonable speeds than what you can see here. But I don't want to move it too fast before I balance it, of course. And then once that's done, I'm going to add all the other stuff to support the engine and the PMG. So once all that is done, I'm going to do some load tests on the PMG, because now I do have the necessary setup to make sure that the PMG is able to handle the load, because now the flywheel is going to make sure that it gets sufficient energy for the high demands that we might have. So if you like this video, click the like button and also subscribe to my channel so that you can get notified once I upload the video for the load tests.